Welcome to our 6th grade Chapter 9 lesson over the coordinate plane. We are going to focus in on lessons 9.1 and 9.2 today, where we are looking strictly at finding coordinates and talking about quadrants, and lesson 9.2 moving into the length of line segments. This is what your Chapter 9 notes packet looks like. If you take a look, it introduces the coordinate plane and also tells us what our objectives are for this unit of study. So objectives, every point on the coordinate plane can be represented by a pair of coordinates. You're going to hear this an awful lot throughout this unit where we're talking about a pair of coordinates. It takes two number values, an x and a y, in order to identify a specific point on the coordinate plane. The x always comes first, the y always comes next. And when we talk about this, I'm also going to remind you that there's a reason for this order. If you think of alphabetical order, we're following exactly the ABC rules. So I like to say A, B, C, D, X, and Y. It's kind of like replacing the song that you learned in kindergarten with a much more meaningful tool for a 6th grader. So the X will always come before the Y. It also goes on to tell us here that coordinates, they are an ordered pair, and again, emphasis on pair, like a pair of socks or a pair of shoes. You're talking about two of something. So it takes two number values to make an ordered pair. So an ordered pair, or numbers, that gives the location of a point on a coordinate plane. This reminds me an awful lot of what you've been doing in social studies recently, where you're talking about lines of latitude and lines of longitude. We use the same process in order to find points on a coordinate plane that we use to find specific locations in the world. Now it goes on to tell us that we're going to study the coordinate plane, which is a grid formed by the horizontal number line, sitting right here, also known as the x-axis, and the vertical number line called the y-axis, located right here. And again, notice how these intersect. It's very similar to your equation, wrong thing, to your equator, and your prime meridian intersecting here, like you have talked about in social studies already. We are going to move on, and I'm going to ask you first to turn to the back of your notes packet. So I'm going to try to get us there really quickly, and we're going to try to take a look at our math maps. So on the very back pages, you're going to see something that looks like this. The first one says we're looking at lesson 9.1. This is an example conclusion map to graphing ordered pairs on a coordinate plane. These maps were made by your 6th grade math teachers, kind of working together, trying to make your learning maybe a little more visual so that you could maybe look at a textbook example and figure out what was going on. Well, if I look, I have 1, 2, 3 different examples here, and when I'm done with looking at those 3 examples, I'm going to try to set a rule. So the rule is what goes here in my conclusion. So I look at my examples, I come up with a rule or a conclusion, and when I'm done, I try my own. So then I get my own practice doing this. So this is really an introductory activity. Can we figure out what's happening here? I'm going to zoom in again real quickly just so that we can see this a little bit bigger in your video. And we're going to look at our examples first. If you notice, I do have an x and a y. I have the x-axis running horizontally and the y-axis running vertically. I also have a point marked right here, and it's got a label. It has a name or a location or identity. It says it's at -3, +4. Well, how is that possible? I don't see a -3 over here, but I do see one down here. That's interesting. There's a -3 sitting here. It's kind of tiny to see, but I do see that there's a -3. And then I notice that this 4 is sitting here. So it seems to me that first they went to the left, and then they moved up. So that -3 in this situation said, hey, go left, and the +4 said, hey, go up. All right, let's see if that seems to be true for this next one. Well, I still have this x and this y intersecting, or the x-axis, which runs horizontally, and the y-axis, which runs vertically. And I noticed they gave me a point here. This point is located at -4, -2, it says. Well, this time I have 2 negatives. And if I look at the numbers nearby, I do see a -4 sitting here. I think those negatives are kind of hard to see, so make sure that they are negatives going this direction. And on this side, I kind of see those negatives got tied in with my horizontal line. So this should also be negatives. Looks like we're at a -2 this direction. So the -4 came first. What that means is I must have to move 4 backwards or behind 0 to -4. And when I'm done, because this is a -2, the negatives are down low or below 0, just like we talk about on a vertical number line. So I'm going to head this direction next. Okay, I'm kind of seeing a pattern to this. This -4 told me to move to the left, similar to the -3 on the last example. But then instead of moving up for a positive number, I moved down for the second coordinate. That -2 made me move down. Interesting. I'm going to take a look at the third example and just see if we can kind of figure out what's going on here, see if we're kind of connecting some good rules. So again, I see the X and the Y, and I remember I already talked to you about ABC order, so A, B, C, D, X, and Y. The X has to happen first in our coordinate pair. And let's see if it does. So here I have my X-axis running horizontally, my Y-axis running vertically. So my first rule is moving either left or right on my X-axis, and then my Y coordinate is telling me to move either up or down. All right, well, with this point, it says that it's located at +3, -2. Well, how is that possible? If you look at your little tiny numbers here on the coordinate plane, I do see a little tiny 3 sitting here. I'll exaggerate it for you right now, and I hope that you can see that there's a little tiny, there should be negatives sitting in front of these, and I'm not sure if I can see them right now, so I hope that you see that there's a -2 sitting here. If not, you might want to go in and make sure we have negatives next to each of those. All right, well, that 3 comes first, so it looks to me like I'm going to have to move 3 to the right first thing. 1, 2, 3. And notice I'm counting how many intervals, so I'm counting 1, 2, 3 intervals. And next, this -2 really makes me move down to get to that point, doesn't it? So a +3 made me move to the right, and a -2 made me move down. Oh, I'm noticing kind of a pattern here. When the first number was negative, I moved to the left. I moved to the left here, and I moved to the left here. But when that first number is positive, I had to move to the right. So the first thing I did is I moved right on this one. That second number also tells me something really critical, doesn't it? Are you noticing a pattern? When the second number is positive, you move up. But these next examples, the second number, or the Y coordinate, was negative, and it made me move down. I think I'm ready to write my rule or my conclusion. So I'm going to try to scroll us there a little bit if I can. So to do what? What is our goal today? Well, if you look again at the top of your math map, it tells us what we are trying to work on. We're trying to graph ordered pairs on a coordinate grid. So to graph ordered pairs on a coordinate grid or coordinate plane, comma, I do what? Oh, well, I first have to determine if that first number makes me move left or right. So kind of like we did with our 3 examples, I use the X coordinate or value to move which way. What did that X make us do? Oh, well, the X-axis moves left and right. It's horizontal, so same idea with the X coordinate. I use the X coordinate to move either left for negatives or right for positives. There we go. We might want to point out what you have to do next, and I know I'm running out a little bit of space here, so hopefully you can make a little bit of room like I'm going to try. So next, we need to talk about the Y value. What does that Y value make you do? Next, move up for what type of Y values? Oh, they were positives. If you look at your examples, that first one was a positive. It's way over there in that top left corner. So we move up for positive Y values, or we move down for what type of values? That was like on these last 2. Well, there's that Y value, that second number, and in both of these it was negative. So we move down for negative Y values. It follows a rule every time. I always read the X before I read the Y, just like in the alphabet, A, B, C, D, X, and Y. I won't sing this in my video for you today. maybe another day. The next thing we're going to do is scroll down here and try an example of our own. And we also have a hawk hint to go by today. So hopefully you're caught up, because I'm going to slide us this direction a little bit. Here it says, hawk hint. Remember, the x-axis is the horizontal number line. Oh, there's that word horizontal. I can picture the horizon, looking out at the sun setting or rising. It says the y-axis is the vertical number line. Oh, the y-axis is that vertical. And remember that V in vertical almost looks like an arrow going up and down? It's the vertical number line. Always plot the x and the y value. Always plot where the x and the y values intersect. So we're really looking for that intersection where the two cross each other. The x and the y both hit. Kind of like your line of latitude and longitude. Where your latitude and longitude intersect, that is the location you're looking for. Well, over here I get to try my own examples. So I would ask you to make up some numbers, but unfortunately I'm in my room alone right now, so I'm just going to make up some values for us. What if we had a -1 and a +5? And then in a moment, what if we had a +5 and a -1? Worth kind of looking at. We're using similar numbers, but will they land in the same location? The answer is no, they cannot. In fact, the order here is different, which means I'm going to have to start in different directions. Notice that we always start at the middle, and that wasn't really emphasized in the top there very much, but I think it's important to show that we always start here at this main intersection where the x-axis hits the y-axis. This is called the origin. So I like to think of where we originate from, kind of like our background. Well, it's thinking to where we always started from. So the origin, it's sitting right here at 0, 0, or this intersection between the x and the y-axis. If I'm looking for -1, +5, I might sing my ABCs, A, B, C, D, X, and Y, to remember that the first number, this -1, tells me to either go left or right. And the next number value is the Y. It tells me to move up or down with that line of longitude, or maybe with that y-axis. Let's try this. If it tells me -1 on the x-axis, starting here at the origin, which way are the negatives? Hopefully you can see that that means to move 1 to the left. But next it says +5, and I have to move on the y-axis, which means up or down, and the positives are heading upward, so I'm going to move from here 1, 2, 3, 4, 5, and put a point. I'm also going to do a really nice job of labeling this for you. All points have an identity. It's kind of like you. You're special. You need a name too. Okay? So we have this -1, +5 plotted. This coordinate pair is shown with 1 point or location on the number line. Let's try this next one. So I've used similar numbers, but we're going to see how this might differ a little bit. So if I say A, B, C, D, X, and Y, like the alphabet that I wish your kindergarten teacher had taught you, because it'd help you out this year in 6th grade, we know that the X coordinate has to happen before the Y coordinate. We have to move on the x-axis, which seems to run horizontally or from the left to the right, and then next on the y-axis, which seems to run vertically, up or down. Well, starting at the origin, we're always starting here at the origin, and it tells me to move +5 on the x-axis. Well, the x-axis runs horizontally. Which way would you move for positive numbers from 0? To the right. 1, 2, 3, 4, 5. Here we are. Don't put a point there yet because we have another location to move. We have to consider the y coordinate, which says -1. Well, moving downwards, we would find -1, and we would put a point. All good points get a label. They get an identity. Do you notice something interesting? We use the same number values, but because they were in a different order, they landed in different quadrants or different locations on my coordinate plane. I think we're ready to dig in a little more closely to the rest of our notes packet. So if you will, you can turn the page and we'll see what comes next. Here we are looking at the second page of your notes packet. So we moved behind our terminology and we're looking at the next page where we have a beautiful example of a coordinate plane or a coordinate grid. There's a lot of great information up above. In fact, if you read those couple of paragraphs, it's explaining what we're seeing here. But I'm just going to take a look with you and see if we can do some of this based on kind of the example. So I want you to notice something that we've talked about before. We've talked about this x-axis, so let's label it. The x is this horizontal axis. We've also talked about the y-axis. The y is this vertical axis, so we want to label that here. The next thing I want you to notice is we have some points located here. I have point A and point B and point C and point D, and they're missing something. They do have an identity because they're given a capital letter kind of as their name or their location, but I think we can do better than that. I'm wondering if you can help me out and we can tell where those points are actually located using their coordinate pairs. So over here I'm going to list point A, point B, point C, and point D. And we're going to try to figure out the pair of numbers that will get us to those locations. So let's take this first example, point A. Well, if I start here at the O, or also known as the origin, where we originate or where we start, which way would I move from these intersections? Well, if you remember, the X has to happen before the Y. I have to move left or right because the rule goes A, B, C, D, X, and Y. It's alphabetical, isn't it? So to move to the A, I have to move over here 1, 2 to the right. That really means a positive 2. I'm moving 2 towards the positives this direction, not towards the negatives, which would be to the back of 0. So here I am at positive 2 on the x-axis, and next I need to move upwards. So the top numbers here, or moving upwards on the y-axis, seems to give me positive numbers, positive 1, positive 2, positive 3. So here I am at positive 2, positive 3. Perfect. It also says that we're in quadrant 1. That's interesting to note. So any value that I get over here in the first quadrant is going to have a combination of a positive, positive coordinate pair. Let's try point B. So point B, starting at the origin here, requires me to move backwards on the x-axis. So first I have to move backwards to the negative 2. That actually gives me my first value, my y value. Sorry, the x value. That is your x value, the first value, right? A, B, C, D, X, and Y. The next thing we need to consider is the y value. So I notice that I have to move up again. I have to move 1, 2, 3 intervals upwards. And if you look across here, that's actually the intersection of negative 2 and positive 3. So those are my coordinate pairs. That is my coordinate pair. Those are my coordinates in the coordinate pair. We're going to try to find point C next. So taking a look here, starting at our origin, which way do we have to move? Looks like we're moving behind 0, so I'm going to move to the left first. So we move backwards 1 and backwards 2 until we find negative 2. That's my first coordinate, or my x value, negative 2. Oh, actually these are on the same line, aren't they? The same vertical line. So that's why they both share that negative 2 as their first coordinate. Interesting. But this time I don't move upwards, I move downwards. I move down to negative 1, negative 2, negative 3. Oh, this is the intersection of negative 2 and negative 3. So negative 3 is my y value. And here I have completed my coordinate pair. This is interesting. This one lands in what's called quadrant 3, and notice they are using these Roman numerals. But in quadrant 3, I had what type of numbers? 2 negatives. A negative makes me go left, and a negative makes me move downwards on the coordinate plane or grid. Oh, that's just the opposite of having 2 positives in the first quadrant. Down here we are in the third quadrant, and I have 2 negatives. Let's take a look at point D. Point D is over here. So starting at our origin, remember, do we move left or right first, or up or down? Well, the correct answer is we move left or right. This x-axis runs horizontally, so always horizontal. Always go find the elevator before you can go up or down in the elevator. So we're moving 1, 2 intervals to the right. That 2 is a positive, and it made me move to the right. 2 is my x value. Next I need to move downwards to get to point D. How many intervals do we move downwards? Well, if you notice, we land on this negative 3 intersection, right? Or that intersection with negative 3, telling me this must be my y value, or my y coordinate in the coordinate pair. Now, we didn't talk about these other quadrant names. So up here with point B, I noticed that this landed in quadrant 2. So if we look back for a quick minute, point B, what type of numbers did it require? First a negative to make you move left, and then a positive to make us move up. So the combination that will always land us in quadrant 2 is a negative followed by a positive, always in this order. So quadrant 2 is sitting here, and again, that Roman numeral. Let's take a look at quadrant 4. This actually says quadrant 4. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. And in Roman numerals, this looks a little bit funny to you, doesn't it? That IV, it actually stands for a 4. Well, what did it take to land in quadrant 4? Look at point D and let's look for a rule. Well, I noticed that the first value was positive. I had to move positively to the right. The next value was negative. I have to move downwards. So it always is going to require a positive number, then a negative number in my coordinate pair. Now you are going to be asked about quadrants more so in these notes today, and also in your assignments coming up, and no doubt on the M-Step or maybe on our NWEA testing one day soon. So let's be ready for that. Do you notice any rule about this quadrant 1, quadrant 2, quadrant 3, and quadrant 4? Oh, I hope they kind of look like when we play 4 quadrants in the classroom, also known as 4 corners. That's why we practice that idea of quadrants in these locations. But I also noticed that the 1, the 2, the 3, and the 4, if I follow them in order, they move counterclockwise. And you'll actually see that word counterclockwise up there in your notes. It's telling you kind of a hint. But what I like to notice is if you start here with quadrant 1 and wrap around to make a C for coordinate plane or coordinate grid, you actually are following the same order as the quadrants. So it makes a giant C for coordinate pairs or coordinate plane or coordinate grid. This kind of helps me remember the order that our quadrants go into. And I also know that most of us have only seen quadrant 1 working in the elementary. So this is kind of new to think, oh, there are other places on this coordinate plane that we've never considered before. When we introduce our integers or our negative numbers, we can move in all locations from that origin. Here we are on the next page of our notes. And this is actually kind of a supplemental notes packet. I found some really great examples online that I was able to copy into our notes. And that's what we're looking at here. So you should be on page 2 with me where it says, let's identify some ordered pairs. So we've done that using our math map. That was that idea on the very back of our notes packet where we saw our awesome hawk hint. So that math map, if I don't remember how to do it, I can always look back and it's kind of a quick glance of a resource on page 8. Now I'm on page 2 and it says we're going to write the point that is located at each ordered pair. So notice that on my coordinate plane, each of these points has a capital letter as its name or its identity. Well, we're going to take a look at which coordinate pair matches those letter names or those points. Number 1 says I have a positive 4, negative 5. And I really want you to review with me A, B, C, D, X, and Y. The X always comes first. We're going to have to go find our elevator before we can go up or down in the elevator. Or maybe you're thinking of at a library, maybe an old school library, where they have those sliding ladders, kind of like you've seen in Harry Potter before, perhaps in the movie. So, or maybe there's a Disney movie, I think, where maybe Beauty and the Beast, something similar. Bella's in the Beast's library and she's sliding around on this ladder. First she has to go from right to left before she can move up or down and find the book she wants. So for number 1, I need to start at the origin. Again, I will remind you, this is our starting point, the origin. I also notice that when I look at these negatives that are below 0, some of those negatives kind of ran into the horizontal line. So you might want to make sure that you can see the negatives sitting there. Positives we won't do anything with because positives are above 0 and positives are to the right of 0 if we're on the x-axis. So starting here at the origin, the x-axis tells me to go left or right. So this must be my x-axis. Let's move to a positive 4, and the positives are to the right of 0. So I move over 4 intervals and I just pause for a quick minute. And for the next coordinate it says negative 5. So we need to move towards the negatives. Down 5 intervals, 1, 2, 3, 4, 5 to a negative 5. We have found point C. I'm going to cross that off because I'm thinking that we found an absolute location. We've used that one up and I shouldn't have to see that again if things are going well. Let's try again, but we're going to look at problem number 2. So we're trying to find the 3, 4 location. So first we'll move first we'll move with the x-axis, right or left. Next we'll move with the y-axis, up or down. Starting here at our origin, we're going to move to a positive 3. And we need to slide the ladder from side to side before we climb up or down. Or go find the elevator before you can choose which floor. So let's move to a positive 3. Positives seem to be to the right. And I just pause there. I don't put anything there because next I need to use the y value to move up 4. 1, 2, 3, 4. Here we are at point P. That's what I'll record. I found that the point P is located at 3, 4. We want to try just a couple more together. I know in particular these with zeros in the coordinate pair are very tricky for my 6th graders. So we're going to tune into those for sure. Let's take a look at number 3 before we get there. So number 3 says, first I want to move -5. So remember, we're going to slide the ladder from left to right, or we're going to go find the elevator first. When we're done, we can choose which floor we want to go to, or climb up or down the ladder, if you will. So here I am at the origin, our starting location. I need to move -5 on the x-axis. Does that mean I slide the ladder forwards or backwards? Hopefully you recognize that means we move backwards to the -5. Just pause, don't put anything. We also need to consider the y value. So should I move up or down for a -4? Well, if you notice, the 4th floor is heading up, but the -4 is heading down. It's kind of like saying you're heading to the basement level. Here we are at H. This next one I know could cause us some trouble, so let's kind of tune into this idea of 5, 0. We haven't seen that 0 before, and this is where my 6th graders usually are doing really great, and all of a sudden they just kind of forget what to do. So take a look at this 5. It's the first value. It has to go with the x coordinate, or the x-axis. The 0 has to then mean how much I move up or down. Well, let's give this a try. Starting at the origin, first I'm supposed to move 5 on the x-axis. So slide the ladder. Should we slide forwards or backwards for +5? Well, the positives are forwards, so here we are. But the next value tells me to move 0. So I'm just paused for a quick minute, and I look at that 0 and say, well, I need you to move to the 0 floor. I need you to move up 0. I need you to move down 0. What does that mean if I tell you to move 0? Ready? Let's jump 0 times. Let's run 0 laps. It means you can't do it. You actually need to stay where you are. So point Z is located at +5, 0. Notice that 0 is neutral. There's no positive or negative to it. So they're also kind of giving you a hint. It's going to stay right on that axis. I'm not going to move to the positives or the negatives. Let's take a look at number 7. So I'm kind of skipping ahead here because I'm worried about these 0 combinations. So the first number this time is 0. That means I'm going to move 0 on the x-axis. So moving left or right, I'm going to find the ladder at 0. When I'm ready, I'm going to move on the y-axis, meaning I'm going to move either up or down for a +2. Well, moving over to our coordinate plane, I'm starting here at the origin, and it tells me to move 0 to the right or left. Ready? Slide to the right or left, 0. I didn't see you move. Try again. Run to the left, 0. I noticed you didn't move. Run to the right, 0. Nobody's moving. What does that mean? It means we stay where we are. The x-coordinate doesn't let me move off the origin for a quick minute. I need to stay here. But I also have to remember there's a y value, and the y value tells me to move up 2 units to the +2. Here we are with point U. I know my students never like my U's. They always think that they're B's. So I give this capital U a tail, which I wouldn't typically do. All right, I hope that this is making some good sense to you. I also hope that you'll be able to help me down below here in just a minute when we talk about some ordered pairs for each of the points. We're actually going to find the values, so we're going to work in reverse. So you might want to take a minute and finish these up. Make sure that you're not reusing any of those points on the coordinate plane. They should only happen one time. Part B. It says we want to write the ordered pair for each point. Well, location is everything, right? We need to figure out which way to move and which value comes first. And we again want to remember the rule of A, B, C, D, X, and Y. The first value will always tell me to either slide to the right or left. Always move to the left or right to find your elevator. You might have to go down the right hall, you might have to go towards the left hall. And next you're ready to choose which floor you're going to, whether you're moving up or down. Let's give this a try. Hopefully you remember all of my negative numbers below 0 on the y-axis should have a little negative with them. So if you see that they kind of got lost here, on your coordinate plane, we want to touch that up. I can see mine are kind of missing. We'll start here at the center, and it won't always be in the center. This time around it happens to be, but it definitely is where my x-axis hits my y-axis. This is called the origin. And to find point H, I notice I have to move first to the right or left. Well, H is heading towards the positive numbers, 1, 2, 3 intervals. After I move positive 3 to the right, I need to move upwards. So I'm choosing to go up a couple floors, 1, 2. So the correct coordinate pair or combination would say 3, 2. 3, 2 helps me find point H. Let's try another. Next for number 12, we're looking for point Q. So I'll start again at the origin, which this time happens to be smack dab in the middle. It's at least where my x and my y intersect, and that will always be the case, no matter if I see just a snippet of my coordinate plane or the whole thing. To get to Q, first I need to decide whether I slide my ladder to the left or to the right. Well, I notice I'm sliding towards the right, and I can stop here when I get to 4, can't I? But I'm not quite to Q yet. I also have to drop down 1. I have to climb down 1 level of my ladder. So if we consider the order that we went in, the 4 comes first. First, we move on the x-axis to the right. When I'm done, I had to move down. So I better not call this 1. Moving below 0 or below the x-axis means a -1. Great, we're set with Q. Let's take a look at point K and see if we can get this one going. So I notice K is over here. I still need to start at this intersection of my x and my y axes. So to do that, I need to move backwards. I need to slide my ladder to the left first. Here I am at -1, and when I'm done, I need to climb down the ladder 2 levels, it looks like, or 2 intervals. So after I move -1 to the left, I move -2 down. This negative told me left, this negative told me down. K is all set. I kind of wish that they had some more challenging ones here, that maybe some were sitting on the x or the y axis. But I'm trusting that we've done a few together and that things are making some good sense for you at this point. No pun intended, point. Something I will ask you to do real quickly, because you're required to do this in your homework, is go back and identify the quadrant that each of these land in. So point H, what quadrant do we call this top right? You can always go back and kind of look at the previous page, and you'll see that this says quadrant 1. So I'm going to just write quadrant 1. In a Roman numeral, it looks like the letter I. How about this point here? We were looking for a point Q. Oh, that landed in this bottom right section. So if this is quadrant 1, I remember quadrant 2 is kind of heading towards the left. Quadrant 3 is below him, because I'm kind of going around like the letter C. And quadrant 4 has those funny letters, IV in Roman numerals. So this Q actually landed in quadrant 4. So I'm going to show that with my Roman numerals. So I'm kind of stretching this exercise to kind of help you with your homework, because you're going to be expected to also say what quadrant these points land in. Let's talk about point K. I noticed that was over here, and it took 2 negatives to get there. Well, it's not in quadrant 1, which is the top right. It's not in quadrant 2, which was a negative then a positive. It's 2 negatives. Quadrant 3. That's what I would label this as, with 3 I's, kind of connected. They're kind of glued together. I would encourage you to try to finish this idea in your notes so that you have also this quadrant practice for me. So I noticed we didn't really find a point that was in quadrant 2. Do you see any that are there? Oh, over here, quadrant 2, anything in this upper left, D, S, or A. Let's see if we can find those. Here's S. Oops, I wrote the wrong thing, sorry. Quadrant 2, D. Oh, quadrant 2. And we also said point A, quadrant 2. So you really could go through quickly and identify quadrants before you even label those points with their coordinate pair if you chose to. And I use that terminology, coordinate pair or ordered pair. They have the same meaning. When I quiz you soon, or when you take a test one day, that could be kind of flexible. It could be an ordered pair or coordinate pair. The idea behind ordered pair means there's a certain order to it, right? The X comes before the Y. Moving on, we're going to take a look at page 3. So we're going to use our knowledge of plotting points or ordered pairs in order to make some shapes, to identify what the shapes are on the coordinate plane. So for this first one on page 3, we will read the directions. It says plot and join the points in the given order. So we're supposed to follow the order that we plot the points. Complete the figure by joining the end points. Identify the shape. So I'm going to kind of help us out here. I'm going to let us identify these, maybe by calling the first ordered pair point A, the next ordered pair point B, the next ordered pair point C, and this last ordered pair point D. That way when we go to label their identity or find them on our coordinate plane, there will be a little less labeling and a little less, mess and more space for us to work with. So let's take this first one. First I start at the origin, and the first coordinate I see is 5, so I'm going to move 5 to the right. Slide your ladder to the right to the positive 5. There it is. Next I see a positive 3, so am I climbing up the ladder or down the ladder? Hopefully you'd recognize we're climbing up. Let's put a point and call this point A. We want to try again with point B, so I still have to move positive 5 to the right. So I'll start here at the origin, moving 5 to the right. But do be careful because the second coordinate, the y coordinate, tells me to move downwards 3. Climb down the ladder or go down 3 floors. Here we are. And notice I'm counting the intervals, 1, 2, 3. Or here at the intersection of -3 and positive 5, I'm going to put point B. Next we're looking for point C. So I'm going to move 2 this time on the x-axis. The x value is a 2. So that means start at the origin and slide 2 to the right. When you're ready, you're going to climb 3 down. 1, 2, 3. Here we are. This is the C, or the point C on my coordinate plane. The next one we're looking for here is positive 2, positive 3. So starting at our origin, we're going to move positive 2, which means slide to the right. And this time climb up the ladder. 1, 2, 3, because that's a positive 3. Now they did tell me to connect these in order, so I should have probably done that along the way. A is connected to B, B is connected to C, C is connected to D, and they probably want me to close in the shape even though they didn't give me a repeated coordinate pair so that I can identify what the shape might be. So I'm going to encourage you that if you are using our 2018 planner, you could look at page R10. So page R10 of your planner would be a great spot to start. So if you're not real familiar with the geometry and the different shapes that we're going to see today, this would be a good spot to look. Well, a couple of things. This looks familiar, and on page R10 you can see this is called a rectangle. But I'm going to challenge you. Sometimes rectangles can be other things. What else is a rectangle? Oh, if you notice in the big blueprint on this page, it also says that it's a quadrilateral. Quadrilateral. Hope I'm spelling it right for you. Yes, I am. Okay, quad means four-sided. Oh, I should say quad means 4. And lateral is talking about how many sides, so it's 4-sided. Are there any other names that this could be? Could this be called a square? No, squares have to have the same length or congruent sides on all 4. Could this be a parallelogram? Take a look at your parallelogram. All it means is that the opposite sides are running parallel to each other. Does it seem true that the top and the bottom will never crash, even if I extended them for the rest of their lives? Oh, yeah. What about the edges here? If I extended these in the same direction forever and ever, would they ever intersect? No. So this is also called a parallelogram. So I'm going to challenge you to think of as much vocabulary or terminology as you can for these shapes. Those are the 3 that stand out to me right now. Let's take a look at number 2 and give this a try. Oh my goodness, holy points, Batman. I actually have point A, point B, point C, point D, point E, and point F. I have quite a bit of graphing to do here. I also notice that your negatives are kind of hiding here again, so your negatives on that vertical number line below 0 should be showing. I think we're ready. If I were to find a -1 and a +2, I'd start at the origin and move backwards 1 to get to -1. And the next number tells me to move up a +2. Here we are at point A. Next I'm looking for +1, +2. So starting at the origin, +1 tells me to slide right or left? Oh, right. +2 tells me to climb up or down? Oh, up. Here we are at point B. And I'll connect those as we go. Oops, kind of hard to see that. Actually, I'll change colors on you real quick and see if that might make it a little bit better. Point B. Good. Let's go ahead and try point C next. So I'm looking for a +2, 0. Oh, there's that tricky 0. Get ready, get set. Start at your origin, and can I move on the x-axis? Yes, it says move +2. Move 2 halls to the right. 1, 2, there we are. And now go to floor 0. Do I get to climb? Do I get to drop down on my ladder? Neither. You're going to stay right here at point C. Let's go ahead and connect these as we go. Next, I'm looking for point D. So again, starting at my origin, I'm going to start smack dab where the x and the y-axis intersect. I don't put anything there, I just kind of hover over it for a quick minute. Might hold my pencil lead there for a second. And I'm going to move +1. That means move to the right 1 hallway, right? I move to the first hallway down to the, shouldn't say down. I move to the first hallway to the right. Next, I'm going to go down in the elevator 2 floors. So here I am at point D. Let's go ahead and connect these as we go. And I'm next looking for point E. I notice that I have 2 negatives. And if you think back to one of our very first topics talking about quadrants, you might know that 2 negatives are going to land me in the 3rd quadrant. So I already have kind of a destination in mind. So I'll start here at the origin. Let's move -1 to the left. You always move left or right before you move up or down. Next it says -2. So after I move to the hallway on the left, I next move down in the elevator 2 floors. I'll put a point and connect them for you, and I'll also label it point E. The last point we're looking for is -2, so it's not positive, and neutral 0. So -2 and neutral 0. Starting here at the origin, we're going to move -2 which way? To the left. We always move left or right before we move up or down. And now it says move 0. You're going to the 0 floor. Well, we actually are here at floor 0, so it means you can't move up or down. We will call this point F, and we need to connect as we go. This shape is not closed, so for that reason we need to kind of close it in. It would be okay if maybe they repeated -1, +2 for us, because then they'd make you come back to point A. They didn't exactly do that, so we'll help them out. All right, going to your planner, page R10. If it's 2018, at least I have you on the right page. I notice that this figure has 1, 2, 3, 4, 5, 6 sides. I'm looking for something that says 6 sides. Oh, over here, it's under polygons, which, by the way, just means we're talking about many-sided. Poly meaning many, and gon meaning sides. Polygons, okay, so it's a polygon. Oops, minus the S. What else is it under polygons? Oh, I see something with 6 sides. It says it's a hexagon. Hex actually stands for that idea of 6, right? Could we call this a parallelogram? We probably would not, because it's tough to find opposite pairs to find our parallel for the rest of their lives. I do see that maybe the top and the bottom would be, or maybe some sides if I was extremely careful. But typically we would not consider this a parallelogram. Is it a quadrilateral? No, it has more than 4 sides. So I think we'll call this a polygon and a hexagon, and we will move on. I'm going to ask you to try the same idea with the following few shapes. So you're plotting points very, very carefully, paying attention to the X before the Y, moving left or right before you move up or down. When you're done, I want you to kind of reference page R10 of your planner, or maybe you have kind of a reference sheet that you could look up even online if you don't have your planner with you, and you're looking for some basic shapes. We're trying to identify as many names or identities as we can for these. The last part of lesson 9.1 talks to me about reflections, or talks to you about reflections, and this is on the very next page of your notes packet. So turning our page, I'm on page 4. So on page 4 you're going to see something that says 9.1 points on the coordinate plane. This is slide 2 from our more typical notes, and it says we're going to find the coordinates of points on a coordinate plane. Points P and Q are reflections of each other about the x-axis. Give the coordinates of point Q if the coordinates of point P are the following. So this is kind of wordy. I kind of want to break it down. We are talking about reflections. Have you ever looked in the mirror? I hope so. Okay, it kind of helps you get ready in the morning. So points P and Q are reflections. It means that they're going to be looking across at each other. So kind of like when I look across at the mirror, I can see my reflection in the background. Now here it says about the x-axis. This is extremely important. I actually would encourage you, if you have a highlighter or a different color, to grab this x-axis. Maybe you can make a straighter line than I am. And remember, this x-axis is horizontal. I want to label it. This is your mirror. This is what we're looking across or through. So if I were to sketch this out, if I was looking at the x-axis right here, and maybe I am up here somewhere above the x-axis, where would my reflection look or be? Oh, that's right, your reflection would be below. What if I tried it the other way? What if my reflection was sitting here? Sorry, what if my image was sitting here below the x-axis? Where would my reflection land? Oh, that's right, it would land above. So this mirror is acting just like the mirror that you see in your bathroom every morning. It's telling you to think about what's on the other side. So it's a reflection. Next it says give the coordinates of point Q. So what it means is I don't know Q. I'm going to find it. So Q is the question. And it says point P are given. Point P coordinates are given or are the following. So we're going to call this point P, but I'm going to call it point P sub 1. I'm going to do that because, oops, sorry, shouldn't have done that yet. I'm going to call this point P, okay? We're going to find point P and point Q, his reflection. Next, I'm going to look for point P sub 1. What I mean is they're calling all of these point P, but they don't have the same locations, so that could get mighty confusing. So we're going to identify him a little bit differently. We're going to have P sub 1 and Q sub 1. Notice it's just a variation on using the same identification tools, right? We're using the same letters, if you will, to identify points, but to be able to tell them apart or to be able to identify which two go together, I'm going to look for the P sub 1 and the Q sub 1 as buddies. Here I'm going to call this P, but it's kind of like the second set. And I'm going to call this Q sub 2 because he's going to be the reflection. Next I would have probably P sub 3 and Q sub 3. Our other options would be maybe to use all different identities. I could have A reflects with B and C reflects with D, etc. But they told me to use P and Q every single time, so I'm going to try it. All right, let's try this first set. For A, it tells me point P is located at -6, +2. So I'm going to start at my origin and move -6 to the left. Always move left or right, slide left or right. Next it moves +2, so climb that ladder about 2 places. I see my lines are a little bit fuzzy, so you're going to do your best to estimate here. We're going to call this point P. Well, point P is above my mirror. He's looking through this mirror, which I hope you highlighted. If I'm above the mirror, where's my reflection going to show up? Below the mirror. And if I get really, really close to my mirror, my reflection's really, really close. If I get really, really far away, my reflection's really, really far away. Well, I'm 2 away from my mirror. So on the other side, I need to be 2 away. We're going to plot on that same vertical line, if you see it, that same line of longitude, if you will, but I'm going to move an equal distance on the other side of my x-axis. This is point Q. Now we're also supposed to give his coordinates. So where is this located? I still move to the left 6, so still starting with a -6. But instead of moving up +2, I had to move down. So that's a -2. Interesting. Let's try this again with a second set of coordinates. So I have P sub 1. I'm going to try this again with a different ordered pair. So I'm going to start here at my origin. It says -2 first. So move to the hull on the left, right? We need to move to the second hull on the left. -2, 1, 2. Just kind of hover here. Don't put anything yet, because next we need to go down to the 4th floor. Downwards, 4 floors, 1, 2, 3, 4. And I knew that because there was a negative sitting there. I'm going to call this P sub 1, just so that you know that he is going to go with Q sub 1 in a second. They're kind of like buddies. They're reflections, if you will. Well, remember that if I see an image underneath my x-axis and the x-axis acts as my mirror, the reflection is going to be over the x-axis. So same idea here. If he is under the x-axis or under the mirror, his reflection will be over. But how far over should it be? Well, it should be the same distance away. So this was 1, 2, 3, 4 away from my x-axis. I'll move 1, 2, 3, 4 units or intervals above the x-axis and call this Q sub 1. We also have to give this its ordered pairs. So its coordinate pair would look like what? I still moved -2 to the left. That part stayed the same, didn't it? But instead of moving down a -4, I moved up a +4. Interesting. I'm starting to notice something. Maybe you are too. Let's try this again with a third set of ordered pairs. So I'm going to find P sub 2, or point P, okay? We'll just kind of label it special because they keep reusing the same darn name, and that gets confusing. So we're going to put this P with a little special identification. So let's go ahead and find 0.45. So starting at the origin, I have a +4, slide 4 to the right, or 4 halls to the right. Next it says 5, that's a +5, so I need to move up 5 floors, or climb the ladder 5 rungs. I'm going to call this P sub 2. Again, I'm just reusing the same letter over and over again, and I don't want to get confused about who his reflection is. Well, if he actually is above the mirror, his reflection has to be below the mirror. Reflections are kind of creating opposites, aren't they? But how far away is this? This is 1, 2, 3, 4, 5 away, 5 units above. So I need to count 1, 2, 3, 4, 5 units below. Here we are at Q sub 2. So we should give some coordinate pairs for this point. If you notice, I still needed to move to the right 4 units. And when I was done, I dropped down instead of going upwards. So instead of a +5, I used a -5. Interesting. I'm starting to notice my pattern is kind of working out. Something seems to be staying the same. And then with the reflection, the second coordinate seems to be changing. Let's try again, but this time with our last coordinate pair. So I'm given 7, -3. So let's start at our origin. Let's move 7 which way? To the right. 7 is positive. We move towards the right on the x-axis. When I'm done, it says -3. So am I climbing the ladder or climbing down the ladder? We're going to move downwards 3 intervals. Here we are at P sub 3. Well, if he starts below the mirror, his reflection has to be above the mirror, and it has to be the same distance away. So this is 1, 2, 3 intervals, or 1, 2, 3 intervals away from the x-axis. So let's move another 3 above. 1, 2, 3. Here we are at Q sub 3. This also needs an accurate coordinate pair. We want to know what location this is in space. So I noticed that starting at the origin, we still slid 7 to the right, but instead of moving downwards, we moved upwards. What does that mean? I don't want a -3, I want a +3. I want you to notice something. So this is where I want you to be observant. So observation. I know Mrs. Hill talks to you about this a lot in science class. It's also pertinent in math. When I'm reflecting across the x-axis, what seems to stay the same? The first value, right? So the x stays the same. But the y does what? It was a +2 and it became a -2. It was a -4, it became a +4. What's happening here? But the y becomes the opposite. Okay, so the opposite. This will only be a good observation when we're talking about reflecting across the x-axis. So this is for the x-axis reflection. So x-axis reflection. I could be more specific in my writing down here. I might want to say in the x-axis reflections, and then this would be a true statement. Let's see what's happening next here in our notes. Oh, we're again drawing and identifying polygons on the coordinate plane. So on the bottom of page 4, I'll scroll there quickly for you. It looks like this is something that we did before. This is kind of a review. We are creating polygons, and again on page R10 of your notes, that would be a great resource for you to identify what polygons you have made. And that ends lesson 9.1. In a moment, we'll pick up with lesson 9.2. So now would be an appropriate time to maybe pause your video and make sure that you are off to a good start on your assignment that goes with us, and finish any undone pieces before you move on. Next, we're moving on with lesson 9.2, where we talk about the length of line segments. So we're still using coordinate plane, we're still using ordered pairs or coordinate pairs, but we're going to talk about the distance or the length of line segments using these tools that we've already discovered. So I am on the very next slide of your notes. This is actually happening on page 6. So page 6 of your notes packet. Slide 1, learn. It says find the lengths of line segments on the X and Y axis. So for the first line segment we're given, they tell me to find C, which is located at 3, 0, and then D, which is located at 7, 0. So let's give this a try. Starting here at the origin. I need to move positive 3. Do you move up or down or right or left first? Well, that positive 3 tells me to move on the x-axis. So we always slide before we climb or drop down. So I'm going to move 3 to the right to positive 3. I'm just hovering here for a quick minute and I look at my second coordinate, which says 0. So can I climb up or down? No, we get to stay right about here. I'm going to label this point C. I've taken care of this coordinate pair or ordered pair, and next I'm going to plot D, which is located at 7, 0. So starting here at the origin, I need to move 7 which way? To the right. So I move out here to a positive 7, and it tells me to move 0 up or down. So if you're moving 0 up or down, it really means you're staying in place. Let's go ahead and connect these to make a line segment. But notice this notation. They're actually saying line segment CD. They're telling me that C and D are connected. And this is how we would read it, line segment CD. That's what this little notation above the C and D stand for. So they're asking me for a length. So the question is the length. How long is this? Well, I could actually start at the 3 and just keep counting until I get here. I could count, that's 1, 2, 3, 4 intervals. So I could say 4 units. Some days we'll be measuring in miles or feet or inches. Today we don't really know, so we'll be generic. We'll say 4 units. But is there another way of doing this besides counting the hops? Because let's pretend one day they give me some numbers that go off the charts. They talk to me about 30, 0 and 70, 0. There's no way I want you to sketch that out. That would be way too involved. So there might be another observation. Could you do something with the numbers that don't match? Well, the zeros are the same, right? So I'm going to kind of point out for you here. Those are the same. They stay the same. What changes? Oh, the 3 and the 7. The 7 and the 3 change. How do I use 7 and 3 to get an answer of 4? What would we have to do here? So I record the changing values. And notice that this time I have to subtract. This makes good sense to me. 4 units is a good final answer. And if you think back to our last unit of study, we were talking about finding distance on either vertical or horizontal number lines. And when we did that, when both numbers were positive, we needed to subtract. That's exactly what we did here. 4 units, final answer. What if we had a different scenario? So let's move ahead here and see if maybe they make it a little more challenging than that. At the bottom of the page, you're going to see slide 2 where we're supposed to practice this. So it says find the length of line segments on the x-axis and y-axis. So we're using the same rules. It says plot the pair of points on the coordinate plane, connect the points to form a line segment, and find its length. So let's give this one a try. We're looking for point G. I need to move -7, 0. Do you know just by looking at this -7, which way will you move? I hope you're identifying you're going to head left. How about for the 0? You're actually going to stay there, aren't you? Let's just do a quick skim of point H. Which way will I move? Oh, 1 is positive, I'll move to the right, but the 0 means I get to stay. Let's give this a try. So starting at the origin, there it is. I move -7, slide the ladder to the left. There's -7. Now it says 0. You can't climb up or down. Your book must be right about here. So we'll call this point G. Let's try the same idea. Let's find point H on this number line. So, or on this coordinate plane. I need to move 1 to the right, and it says 0. Stay here. So this is point H. It did tell me to connect these points because I'm trying to find the length of a line segment. So I'll try to make this as straight as I can. And I'm trying to find line segment GH. So I can show it with that fancy notation. I just put a little line segment right over the points G and H. And this really says I'm trying to find the distance. So like we did before, I know that we could just count hops, right? Start at the -7 and let's count heading towards point H. 1, 2, 3, 4, 5, 6, 7, 8. Looks like I'm going to get an answer of 8 units. And that's all fine and dandy. I could call it 8 meters or 8 feet or 8 miles if they told me a little more information. I know 8 units is a final answer, but I want you to be really cautious because one day soon they're going to step up these numbers. It's not going to be like -7, it's going to be like -7,000, and it's not going to be like 1, it's going to be 1,000. So I'm going to need to figure out another rule for this. Take a look at my ordered pairs. Do you notice what stayed the same? The second term, the second value is the same. So we're going to do the same thing we did a minute ago. We're going to record the unlike as a non-repeated. I don't remember what word I used earlier. The unlike values. So the things that aren't alike is this -7 and this +1. How can I use this -7 and this +1 to get an answer of 8? So I'm just trying to push you towards kind of a rule that will work each time. Well, if this -7 wasn't negative, I could add them, right? What could I put around this -7 to make it more positive? Maybe you're thinking we're talking about distance. We could use absolute value bars, right? I could put that absolute value around both of these values and add them together. This probably is looking a little bit messy to you. I kind of would agree. I think it might be better if I wrote that horizontally. The absolute value of -7 plus the absolute value of +1. I'm adding distances together to figure out a total. Well, -7 was 7 away from 0. +1 is 1 away from 0. If I go ahead and get rid of the absolute value symbols, I can just treat this as a distance of 7 plus a distance of 1. 8 units. Interesting. So how come I added this time and subtracted last time? Well, that's because I started with a -7 and I was moving to a positive number. I actually had to cross 0 and keep on going. So this is true whenever I have a negative distance. It's not a distance. A negative number. I'm trying to figure out his distance away from 0 and still go farther into the positives. So in this case, I get a total of 8 units we had to add. Let's see if we can turn the page here and apply one more idea to lesson 9.2, this idea of length of line segments. So the rules reviewed on this page kind of connect to chapter 2, where we talked about distance on a number line. We're going to use that same idea to explore a little more challenging situations. So this is on the next page. It says to me, this is page 7 of your notes packet. Oops, I feel like that says something different than mine. Sorry about that. We're on page 6. Slide 3, learn. It says find the lengths of line segments parallel to the x-axis and y-axis. Oh, there are no zeros this time. If you take a look, we're not staying on the x-axis or the y-axis. We're moving off of them a little bit. So I'm going to try to figure out the length of line segment RS. So to find that, I first need to plot point R and point S. So point R is sitting here at +2, +2. 2 to the right, 2 up. And you kind of have to estimate. I can see our lines got a little bit faint here. Next, we're looking for S. That's located at 6, 2. So I'm going to move from the origin, 6 to the right for +6 and up 2. Should be on that same horizontal line, point S. Remember, we were talking about length of line segments, so I'm going to connect those to make a line segment. And what's really great is these are really hard to count right now. I can't exactly see the intervals, so they're kind of forcing me to think about something different. Do you see how something stayed the same? Something in these 2 points is identical. Is it the first coordinate or is it the second coordinate? Oh, the second coordinate stayed the same. Okay, those both match. Stays the same. So the thing that changes is the first coordinate. I have a 6 and I have a 2. Notice that they both are positives. I want to figure out how far from 2 to 6. So I could probably come down here and kind of count my hops from 2 to 6. It'll kind of help me line up what's going on here. 1, 2, 3, 4. Or maybe I could do what they're trying to show me. I could think of the absolute value. They're telling me that I could take the x-coordinate of 2 and the x-coordinate of 6. And actually I put those in the wrong order, didn't I? Darn it. And I'm supposed to subtract them. Why is it dangerous to subtract 2 and 6? Well, if I do that, I'm starting with a smaller number and trying to subtract a bigger number. So I probably should rewrite this. We're looking for the absolute value of the x-coordinate of 6, and we're going to take away the absolute value of the x-coordinate of 2. I'm going to do subtraction. Both numbers were positive. If they're on the same side of 0, we can subtract to find their distance. And again, I don't know if I'm using feet, miles, inches, meters. I'm going to call it units. We're going to be generic for this one. So I probably would give you a final answer. Line segment RS equals 4 units. I want you to kind of use this idea of absolute value, or at least noticing that if they're on the same side of 0, we get to subtract. So this was true when I had 2 positives. It might also be true if I have 2 negatives. At the bottom of this page, we have another example on slide 4. It says guided practice. Find the lengths of line segments parallel to the x-axis and y-axis. That means that they won't actually be sitting on the axis. They'll actually be parallel or heading in the same direction. Plot the pair of points on a coordinate plane, connect the points to form a line segment, and find its length. So we're doing a lot. We're plotting points. When we're done, we're forming a line. Oops, line segment, sorry. And when we're done with that, we're finding the length. So there are 3 parts here. So just to dissect your directions a little bit, I see some students recently on a test with multiple directions are kind of struggling, so you might want to kind of piece that out a little bit. First, we need to plot the pair of points. So let's do that. Point J. I start at my origin and I move -1 to the left. Next, I need to move -6, dropping down. I'll call this point J. Next, I'm looking for -1, +4. So -1 means slide to the left or move to the hallway on your left. Next, I'm going to move up 4. So pushing the elevator button, going up 4, here's point K. It did tell me, that was step 1, to plot the pair of points. Next, it tells me to form a line segment. So I'm going to try to make this as straight as I can. Notice that they should be on the same vertical line to make this work. And the last thing it says is find the length. So I'm going to show, I'm looking for the length of line segment JK. To do that, this one's a little bit trickier, isn't it? Because it's heading vertically. It is parallel to the y-axis. I could maybe go kind of alongside of it here and count my hops. I could count from the top to the bottom and see how many hops this is. That probably would work. But one day when we give you some really huge or off-the-chart numbers, you might want another strategy. So let's think about this. I could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks like I'm going to get 10 as an answer. Well, what numbers did I use to get there? I'm not using the thing that stayed the same. I'm using the numbers that are different, or the values that are different. I'm using this -6 and this +4 somehow. Well, what do you do to a -6 and a +4 to ever get to 10? Gosh, I bet you're looking at this and wishing that that negative was gone. Because if that negative was gone, that would be like saying 6 + 4 gets me 10. How can I make that -6 turn into a +6 so that I could just add the values? Aha! This is reminding me of distance, absolute value. So it would probably be better to write this horizontally again. The absolute value of -6 plus the absolute value of 4. We're going to add the total distance. This is like vertical distance when we were talking about helicopters and mermaids, oh my. So I'm going to figure out how long this line segment is using a different rule, using the rule of distance or total distance. -6 is 6 away from 0, and 4 is 4 away from 0. If I add 6 plus 4, I will get a total of 10 units. So how come this time I added? That's because my first y value was negative, and my second y value was positive. I had to move clear from the negatives back to my x-axis and then keep on going. Whenever you are crossing the axis along the way, moving from a negative to a positive or a positive to a negative, we're talking about total distance. You might want to think about absolute value or consider adding those numbers, those number values. Here's the last page that I thought we were already to. So let's take a look at slide 5. This is on a page before you get to your math maps. So again, page 7, it says slide 5. So a couple ways to identify this. Oh, interesting. My coordinate pair already has something on it. And I also like this one. You can notice that my origin is kind of shifted, right? That's okay. Sometimes my origin will not appear smack dab in the middle of my coordinate plane. Sometimes I'll just see kind of a snapshot, just a small picture of what we're working with. So I kind of like that this is showing for you. It says, plot points on the coordinate plane for a real world problem and solve it. The side length of each grid square is 2 meters. Oh, each side length. We've been counting by ones, and this time they say each side length is 2 meters. Take a look. Starting from the origin, they count 2, 4, 6, 8, 10, 12. And then moving above the origin, on the y-axis, they count 2, 4, 6, 8. Oh, they're definitely using units of 2. They want me to find the length of AD. And I kind of wish that they had shown this as line segment AD. So we will answer it that way. Let's go ahead and say line segment AD and try to figure out a length. Well, from A to D, you could definitely count hops. You could also do something else. You could identify these ordered pairs and consider the distance. So let's try that one first. How far to the right is A? 2, right? Lands on the 2. How far up is A? Oh, here it is. It stops at the 12, heading horizontally. Or heading upwards, I should say, like a line of latitude. How about point D? Which way did I have to move first? To the right, to our 12. That's your x value. And then what did we have to do next? We had to move upwards. We had to move to the 12, heading upwards, a positive 12. I notice something stays the same. The 12 and the 12 are both in the second position. They're both my y values. So the piece that's changing is the 2 and the 12, the x value. So I need to do something with the 2 and the 12. But what? They're both positives. So I would say I need to take the absolute value of 12 and I need to subtract the absolute value of 2. Or you would just say that's the same as 12 minus 2, which gets us what? 10 units. Oh, that's not 10 units. Silly me. What should it actually be? It should actually be 10 meters. I kind of want to look at this idea. If you decided to do the hops, what would happen? So I notice we have 2, 4, 6, 8, 10, 12, 14, 16. Looks to me like I'm doing something wrong. Oh, and I figured out what it is. It said I can't read this number. I think we're going to rewind because there's no way I want to start this whole video over again. I think I'm about an hour into it. That's too much. So forgive me if I erase, and you might want to do the same. I just noticed something. I do have my glasses on tonight, but that is an 18, my friends. So I'm glad we went back to check. All right, if we think about this length from A to D, we also need to consider the coordinate pairs with the correct values. So this is still 2, 12. Good. But this is not a 12. This is 18 to the right and then 12 up. If you notice, the 12s are still staying the same. I'm going to kind of ignore them because the changing piece is the x value. So in order for me to find this, they're both positives. I would have to say the absolute value of 18, take away the absolute value of 2. Oh, that's the same as 18 minus 2, isn't it? 18 is 18 away from 0. 2 is 2 away from 0. I should get a distance of 16. And it's not going to be units, it's going to be meters. Let's see if line segment AD is in fact 16 meters. Okay, we'll check with our hops this time. Now if I counted, I'd count 1, 2, 3, 4, 5, 6, 7, 8. Well, how can that be? I got an answer of 16. Oh, I hope you realize that we're counting by 2s. We count 2, 4, 6, 8, 10, 12, 14, 16. All right, we're doing better now. All right, let's try another one. So next it asks me to find the width. We're going from A to B. So we're talking about point A here to point B there. I can do this a couple ways. I could count my hops, but it might be dangerous because remember they're counting by 2s. So another way to tackle this might be to record the ordered pairs. So let's try that real quickly. We're going from point A to point B. Point A is located at positive 2 to the right. Use the intervals that they give us, the labels that they give us here. 2 to the right, 12 up. How about point B? Where's this located? Well, it's still 2 to the right, but they only move upwards 2. This first interval intersects with 2, 2. So I might cross out the things that look the same to me. Look at both ordered pairs. I notice there are a lot of 2s, so do be careful. But do the first coordinates or the second coordinates stay the same? The first coordinates stay the same. I kind of get rid of that information. So I really want to compare 12 to 2, don't I? And notice they're both positives. When I have two positive numbers, I'm allowed to subtract. They're on the same side of 0. What does 12 take away 2? The answer is 10. So I'm going to tell you that line segment AB is 10 what? We're measuring here in meters, and I just want to confirm that because I goofed before. So if I were to start here at A and move to B, let's count our hops, or our intervals 1, 2, 3, 4, 5. You might say, well, how can that be? I got an answer of 10 meters, and here I only see 5 jumps. Ah, they were counting by 2s. So we need to do the same. 2, 4, 6, 8, 10. 10 meters it is. Now they're pushing us a little bit here, aren't they? Because next they ask us to apply what we've done when we find our length of AD, and I unfortunately erased it, so I might have to think back for a quick minute and figure out what that was, to our length of AB. We should be able in a second to give you the area using length times width. Or sometimes we say area is the same as base times height. And I guess looking at your planner, this is on page R10 again. It says area equals A times B. So, or area of a parallelogram is B times H, base times height. So your planner this year may record it a couple different ways. It may say A times B or B times H. It still means the same thing as length times width. I need some number values in here before I can do that. So I have to think back for a quick second. You're lucky you have notes in front of you. I just erased mine. 2, 4, 6, 8, 10, 12, 14, 16. This was a length of 16 meters, wasn't it? AB was a length of 2, 4, 6, 8, 10. 10 meters. And notice I had to count those by 2s to be accurate. Well, in order to find the area, it might be wise to label this. Line segment AB going from here to here is 10 meters. Line segment AD going from here to here is 16 meters. Well, how do you find the area? That means how many squares are inside. You can count up those squares if you want to, but you might run into a little bit of trouble because notice they're not counting by a single unit. So you'd have to consider that when you kind of talk about a conversion. Another way to do this is just to plug in the numbers. So what this means is the base is 16. It's 16 wide, okay? And the height, well, that is 10 tall. So 16 times 10, well, if it was 1 times 16, we'd get 16, but because we're multiplying by 10, we get a 0 at the back. Notice I'm still measuring in meters, but I was talking about how many squares would fit in here. And actually, I'm talking about how many squares would fit in here total. That's quite a few. It's meters squared, because I'm talking about area. Final answer. When I'm finding area, it will always be squared. Area is always talking about how many square units. The last one I'm going to do with you here is the perimeter, where it says I'm looking for 2 times the length plus the width. Now, you have not really seen this formula before. This is kind of moving us into middle school and high school thinking, where you're going to be given a formula and just plug in some values. So we could try that for sure. But I know for a fact that you have seen something else. You have seen the total of all sides. So you know how to find the sum or the total of all sides? We might try that first. So if this side is 10, the other side here is 10. And if the top is 16, the bottom must be 16. And in order to find the total or the sum, I would have to add all those together. So that's like saying 10 plus 10 plus 16 plus 16 and finding a total altogether. Notice how they actually used the length twice and the width twice. That's why this formula says what it does. It says 2 times the length plus the width. So it should also work that way. We'll test it both directions, I guess. 10 plus 10 is 20, and 16 plus 16 is 32. I'm just kind of doing some number bonds here to help myself out. If I go ahead and add these together, it looks like I get 52. But we're talking about perimeter. That's actually a linear measure. So we're just going to call this meters. It's actually a straight length. That's our perimeter. Does it work with this formula? Well, let's clear everything out and try to remember that 52 meters. In fact, I'm going to write down here, we think it equals 52 meters, just so that I don't forget. Well, trying the formula instead, I remember this was a length of 10, this was a width of 16. How would I apply this? What this says is 2 times, that's what that dot stands for, and inside this quantity, or these parentheses, I have the length, which we could call 16, and the width, which I could call 10. Or you could even turn those numbers around and it should still work out. Well, what happens if I follow my order of operation rules? Here I'm thinking about PEMDAS. Do I have any parentheses? Yep, let's take care of this first. What's 16 plus 10? Oh, that's 26. I'll bring down my parentheses and I'll bring down my multiplication and my times 2 here. And the last thing, no exponents, but I do have multiplication happening right here. Those parentheses, maybe I didn't need them on there. They're only holding that 26. But they are showing me that I'm going to multiply 2 times that quantity. 2 times 26 is, like 2 times 20 is 40. 2 times 6 is 12 more. Looks like I'm going to get 52. Does it check out? Sure does. So I'm not sure that you're going to remember this formula for perimeter. I'm not sure if you look in your planner here and you see something that looks similar. In your planner, it's listed as this, 2 times the quantity of A plus B. So it will work every time, or if you just want to remember to add all sides, we'll be able to get to a perimeter pretty quickly. Number 3 says palm tree is at E. Oh my goodness. 12 meters from AB and 4 meters from AD. We're trying to find a palm tree. This will be the last thing that I think we try on this one. Oops, as I toss my planner. Sorry, you probably heard that. So using the same coordinate plane, because it kind of ties to slide 5, let's see if we can find something that's 12 meters from AB. So here's AB, and I'm looking for 12 meters. 12 meters away. Well, I'm thinking that if I headed behind this, I'd be in a negative location. And while that would work for lines of latitude and longitude, I'm not sure it will work for our image that's here. So I'm going to think that I need to move 12 meters, maybe heading positively. And remember, we're counting by units of 2. So I'm going to use a different color here and count 2, 4, 6, 8. Whoops. Sorry, that got a little crowded because I can't see my intervals. 2, 4, 6, 8, 10, 12. I'm thinking this direction. I'm thinking I need to move somewhere over here about 12 meters away. But then it goes on to say 4 meters from AD. So I'll try to use a different color here. AD is this top edge. We found that before, didn't we? And we're talking about 4 meters away. So I could probably move upwards 4. I could move downwards 4. It doesn't tell me a whole lot of information. So I'm going to trust that they're talking about putting this inside the fence. So in this situation, if I were to count 4 meters away from this, I would have to head this direction, downwards. 2, 4. I need to think about moving somewhere where this intersects, 4 meters away from AD. And actually, maybe I would have counted my 2, 4 over here and had to think a little bit more. It looks to me like my palm tree might be sitting right about here, and I'm not sure we can see my palm tree. Okay, I'm going to label it palm tree. So I also can move a certain distance, kind of thinking of those intervals away, and try to find an intersection to try to make this true. So we'll call this point E, because in the problem they call it point E. It's located at point E, and we're supposed to give its coordinates. So my choices here are moving to the right until I see the 14, which is positive. And then we had to move up until I hit that 8 with my horizontals. Positive 14, positive 8. Maybe another thought here. Again, they didn't tell me to put this inside the fence. What if they told us to put it outside the fence? The only thing that would change, you would still move over here 12 meters from AB. But instead of moving downwards 4 meters, maybe you'd move upwards to 4 meters. And there might be a different intersection. So maybe this is your palm tree. I guess they would have to give me a little more context, so I'm sorry that they did not this time around. We want to figure out point E, if it's outside of the fence, might have a different coordinate pair. So I'm just going to call that E sub 1. It's a different point, a different possibility for the palm tree until I get a little more context. Notice I still move to the right until I hit the 14, and I still move upwards. I climb the ladder until I get to, ooh, kind of off the charts. It goes one above the 14, so we're counting by twos. That must be 14, 16. Couple possibilities. This one I'm not sure about because, again, we don't know if they want this inside the perimeter or outside the perimeter. With that, I'm going to stop here on your notes. I'm going to trust that you have a few great examples to be able to start your assignment. We probably will look at slide 6 when we are in the classroom, just so that we can kind of talk through the challenge that this one will present. Today, I think that's probably enough to get your assignment going. And if you want to stop my notes here, you can. If you want to take slide 6 with me and just finish this very last step, you can do that as well. Here it says in the diagram, triangle ABC represents a plot of land. The side length of each grid square is 5 meters. Oh, they're counting by fives this time. That's interesting. So down here I see 5, 10, 15, 20. Notice they're not counting by negatives. We don't have a negative shown because you wouldn't count a negative distance, would you? Use the diagram to answer questions A and B. A, give the coordinates of points A, B, and C. Oh, we can handle this. I probably would want to show this in a nice organized way. So I'm going to try to find a location to list these for you. And we're just going to think about the ordered pairs. So this one doesn't scare me too much, except that instead of moving 2 to the right, I'm actually moving 10 to the right. And instead of moving up 1, 2, 3, 4 intervals, I need to call that 20 because they're counting by fives. We want to try the same thing with point B. So moving 2 intervals to the right, but they're counting by fives, so that's actually 5, 10 units, if you will. And they're moving up 1 interval, but it's an interval of 5, so 10, 5 is good. Point C, we're going to move all the way over here till we hit that 30. So I'm going to record 30 as my X value, and what would my Y value be? 20. We've done part A. Part B says a pole is located at D on the plot of land at a distance of 10 meters from AB and 5 meters from AC. Give the coordinates of point D. So a pole is located at point D, so I'm trying to find point D. Where is it? So point D is kind of the question mark. On the plot of land. So if this is a plot of land, it's got to be somewhere inside. This time it's telling me put this point inside somehow. It says it's a distance of 10 meters from AB. So here's AB. I need to move 10 meters, and I don't want to move away from the plot of land. It tells me to move towards. So 10 meters. I can't count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll go off the charts. And not only that, I have to remember they're using intervals of 5. So I could count over here maybe 5, 10. And I'm thinking to myself, okay, I'm going to look for an intersection here in a moment to find the missing piece or the missing pole that goes at point D. Well, the other hint that they gave me, besides 10 meters from AB, which I already did, is 5 meters from AC. So here's AC. Well, maybe a different color will pop out at us, AC. And I'm looking for 5 meters, and I don't want to move outside of the perimeter. They told me to keep it inside the plot of land this time. So it says 5 meters below. Well, if I'm counting by fives, that really means let's just take 1 hop or 1 interval of 5. So I'm looking for something along this line of latitude, if you will, or something along this horizontal. Well, I noticed that these two intersect right about here. And this is really a challenge problem. This is probably over and above what some of us are feeling comfortable with today. So that's why I said you had the option to keep on sticking with me or to maybe call it a day and actually start your assignment. But if you're ready for this challenge and you're able to consider counting by a different interval besides ones, you can talk about where those possibilities might intersect. And notice it's inside the plot of land. We're supposed to find its location, I'm guessing. Well, let's go ahead and dig in here and see what it says. Plot points on the coordinate plane for a real world problem and solve it. D is blank grid squares to the blank of AB. Oh, so we know it has to be how many grid squares from AB? 1, 2. So D is 2 grid squares to the which direction? Right. That's exactly what we did with our hops. We moved 2 intervals, or 2 grid squares, or 10 units, 5, 10, to the right. D is blank plus blank. D is blank plus blank equals blank grid squares to the right of the y-axis. So if you notice, it is talking about not only my 2 additional grid squares, they're talking about where I started. So this point, or this, sorry, vertical line or line segment AB is actually 2 intervals to the right of the y-axis. So if I started 2 intervals away, 1, 2, I need to move 2 more, it says. So 2 plus 2 makes 4 grid squares away from the y-axis. So they're kind of talking about, hey, if I started here, I need to move 1, 2, 3, 4 intervals away. That's not exactly how we showed it in our image, but we'll try to fill in their pieces and still get a good answer. The x-coordinate of D is something times something equals the unknown piece, right? So the x-coordinate, if my x-coordinate here for A was located at 10, and we won't worry about the y-coordinate for a quick minute, the x-coordinate is 10, meaning 10 to the right, I need to double it. It's like saying I needed to double the distance. So 10 times 2 is 20. I know that this should be sitting at 20 something, and it is. The x-coordinate is at 20. The y-coordinate we'll figure out in a minute. Let's take a look at this next piece. It says D is blank grid squares to the something of AC. So here I had AC, and how many grid squares did we have to move away? Just 1, and we had to move 1 below AC. So in this situation, it's kind of like saying D is located at, we consider our original height, and we're going to take 1 away. So instead of adding 2, like we did last time for 2 grid squares, we're going to take 1 away. So let's figure out our original height here, moving up to this line segment. This all is, I guess I'd say, parallel. It's all parallel. Line segment AC is parallel to the 20 on my coordinate plane. So I'm going to use this 20 as kind of my guide. So D is 20 minus 1 equals blank grid squares above the x-axis. It should be 19 grid squares. Oh, sorry, they're talking grid squares, not a distance. That's a bad move on my part. Too bad I don't know how to edit my videos and you get to bear with me here. Maybe one day. So instead of 20, I'm actually talking grid squares. So I should probably think of it this way. Oops, on a pen. I am 1, 2, 3, 4 original grid squares up. And I'm removing 1 grid square from that. So I need to be 3 grid squares above the x-axis. That's exactly what we showed here. I'm counting up just 3 of them. 1, 2, 3 in order to find that intersection. Well, it says the y-coordinate of D must be. So it's like taking our original y-coordinate. The original y-coordinate is like saying it's 20. And why are we multiplying? Let me think about this. Well, we said that it's located at 2020, so I kind of want to see if I can make sense of this. Oh, I gotcha. It looks like it looks like another mistake. I so want to edit my video, and I'm so sorry. This many hours in, I can't do it. Maybe next year we'll make it better. I noticed something when I went to do this. I'm not moving up 20, am I? I'm moving 5, 10, 15, up 15. And so just using this model will help me. And then I'm trying to figure out, how did I get that 15 over here? Well, if it's 3 units or 3 grid squares, each one was worth 5, right? It's kind of like saying, I'm bothered by that too. We might want to go back and think about this one too. It's like saying I have 3 units times 5 should get me to that 15 on my horizontals, and it does. It gets me to 15 on my horizontals. I just need to double check that. I'm trying to look back here. My 10, 20 seems to have gone wrong maybe. I'm over 10, I'm up 20. No, that's fine, that's point A. I'm trying to think about this right here. the x-coordinate of D is not 20. It is 20. This is what I'm missing. The 4 grid squares, that's what we're going to plug in here. We have 4 grid squares times 5 in each, meaning we're counting by intervals of 5. We do get to our 20. Ugh. All right, teachers are learning new things all the time. I wasn't sure I was putting this in our video or even going to take you there today, so perhaps I should have previewed it a little bit better. I think in this situation, this model is definitely helpful. I think that even a quick sketch, if you don't have a coordinate plane, will probably help us to do a better job of counting those intervals. I'm not sure if I love the template here or the framework, but we were able to kind of struggle through it. And I need to be honest with you, sometimes math lately, for all of us, we have to show what's considered kind of a positive struggle, right? It's kind of like we don't give up on things. It's kind of that perseverance that we talk about in the classroom. With these, I think we're ready to return one last thought to our math map. The very last one, which is talking about distance on the coordinate plane. So if you want to sum things up today, if we're trying to find distances, and this is a lot nicer than the template I think that we just looked at on the last slide, we have 4 examples on this very back page of your notes. So I'll turn here with you. This says it's on page 9. This is a quick place to glimpse if you're trying to figure out how to find a total distance. So in example 1, I noticed that they're counting the hops, and they end up getting 4 hops and they end up getting 4 units. I also noticed something else. Unless I'm not on a pen, that could be a problem. I noticed that they're also adding this distance of 1, the distance of 1, and distance means absolute value, and the distance of -3. We're adding them together to get to 4 units. That makes sense to me. And notice we're going from the positive side of the number line to the negative side. We needed to add. This next example, example 2, says we're still finding the length of a line segment, but I notice that they're using different intervals. Here they're counting by those 3s, aren't they? So to do that, while I can count 1, 2, 3 hops, it's kind of like saying 3 times 3. Or I might consider kind of using these coordinates. They're starting at the 0 and they're moving all the way out here to 9. So the pieces that are changing is like saying the distance from 0 plus the distance to +9. Oh, that gets us 9 units. This next one, I noticed that we're crossing the y-axis. So here's the y-axis for you. They're going from a -20 all the way over here to a +20. And I could count by units of 10 because these are intervals of 10. 10, 20, 30, 40. Or another way of doing that might be to say the distance of -20 plus the distance of +20 added together. Well, these both are 20 away from 0, so 20 plus 20 gets me the 40 units that they're talking about. And that addition step will always be true if I'm moving from a positive to a negative side of the number line. And this last one, we gave you another example moving from a positive to a negative, but this time moving vertically. So we're going to apply kind of the same rules. I could count my hops, 1, 2, 3, 4, 5. But notice they're counting by intervals of 5. So 5 times 5 gets me 25 units. Or another thought, we could use the y value. So I could talk about this is located at +10, +10. This h is located at +10, -15. We take out the things that stayed the same, the x coordinate stayed the same, and talk about the distance between +10 and -15. The distance from +10, or the absolute value of 10, plus the absolute value of -15. Now this is not a fabulous example because each time in my examples here we're crossing an axis, aren't we? We didn't really get to see the subtraction method of this, but that's okay. So 10 is 10 away from 0, -15 is 15 away from 0. If I add together, I will get that 25 units. This is another example conclusion map. So we are supposed to take what we've seen here, sum it all up so that you have a quick glance and a quick reference. Well, let's see if I can get there. So what seems to be the rule? First of all, we need to figure out what is it that we're trying to do in this situation. To find the length of line segments, right? I need to do what? I need to add the distance to the positive with the distance to the negative, right? I need to add both distances. Maybe I say both distances. From 0. And this is only true when what? When we cross the axis. Whether it's an x-axis or a y-axis, you're moving from a negative to a positive. Okay, so to kind of sum it up, usually at the bottom we ask you to give an example, but it looks like that kind of got chopped off, so you will not have to give one of your own. I would only say an alert, a caution, oh my goodness, and I don't know if my caution sign is heading the right way or the wrong way. Will this also be true if I'm keeping in the same side of 0? If I'm staying in, say, the first quadrant, or if I'm staying in the second quadrant, will I still have to add? The answer is no. If you're staying in the same quadrant, or same side of 0, you will subtract instead. So kind of a caution, an alert, something to think about, which is outside of this math map. Just to kind of sum it up, sometimes you will have to use another strategy. I do want to apologize for my errors throughout. Sometimes we call that productive struggle. You definitely saw it from me today. And again, I wish I knew how to edit a little bit better, so someone step up, one of my students, and help me out. That last one got a little bit nasty because I don't like to think inside boxes, and they gave me a lot of boxes to fill in, didn't they? So do be open-minded about the way that you process the problem. If you don't work inside those boxes or the template that they give you, maybe we would just write right over top of it. We had figured out a good answer prior to that, I think. So be flexible. Know that sometimes we do struggle. I definitely did today. And maybe it was good that you got to see it. So again, coordinate plane, just lessons 9.1 and 9.2 is what we're tackling. We're going to try to wipe this out before we move into chapter 3. So applying our number line number sense to positives and negatives using the coordinate plane.